The purpose of this video is to run through the different types of randomization distributions that you might have to construct using StatKey in order to compute p-values. When you're constructing a randomization distribution using StatKey, everything you need is over here, underneath the heading Randomization Hypothesis Tests. We'll need the first four options right now. Slope and correlation we're not going to need at this point. Just like with confidence intervals, we're not going to do anything with slope or correlation until the end of the course. First option is a single mean, which is certainly what we've got here. We have quantitative data in a single sample, so single mean makes sense. The first thing we're going to need is the hypotheses. So look at the first sentence in the second bullet point. A researcher wanted to see if there's evidence that the average has changed. So changed does not specify a direction. We're going to need a two-sided alternative, a not equal to in the alternative hypothesis. Essentially, we're looking for evidence that mu is not equal to 18. So that's what our hypotheses should look like. Using StatKey, the option we want is test for a single mean. And we're going to have to do two things. We're going to have to get rid of the preloaded sample data and put our sample data in there. And we're also going to have to adjust this value in the null hypothesis. I would put in the sample data first and then adjust the null hypothesis. It doesn't matter with a mean, but it does with a proportion. If you do it in the other order with the proportion, you'll have to readjust the null hypothesis, and it's easy to forget to do that. For some reason, StatKey is finicky about that. So I'm going to put in the sample data first, dump all this preloaded sample data, and I've got it right here in this notepad file. So I'll copy that, paste it over, and then change the value in the null hypothesis to 18. Then we can generate 5,000 randomization samples. And it was a two-sided alternative, so we want two-tail of the three options up here. The cutoff is right here. It's the mean from the original sample, which is 25.7. Since this is a two-sided alternative and 25.7 is bigger than 18, the thing that we're going to adjust is the right tail. So I'm going to change this cutoff to 25.7. And there we go. The p-value ends up being 0.0056, which you would get either from doubling the right tail or adding the left and right tails together. Next is a single proportion. If you look at the third bullet point where it says the company will market the yogurt if more than 30% of people like it and we want to perform the appropriate hypothesis test, so we're looking for evidence that more than 30% of people like it, so we're looking for evidence that p is greater than 0.3. That's what our hypothesis should look like. If we're looking for evidence that p is greater than 0.3, that should be our alternative, so that means the null should be p equals 0.3. In StatKey, the option you want is test for single proportion. To put our sample data in there, we had that out of 400 people, 128 liked the yogurt, so 128 divided by 400. Then change the null hypothesis value to 0.3. Then we can generate 5,000 randomization samples. And this is a one-sided alternative. There was a greater than, so greater than is a right tail. And then the cutoff should be the sample proportion from the original sample, which is 0.32. So I'm just going to change this cutoff to 0.32. And there's our p-value, 0.212. Next is a difference in means. We're going to compare the average amount of caffeine in 1 pound jars of 2 brands of coffee. We have our sample data right there, and then just like before, we want to set up the hypotheses first. So that last bullet point, is there enough evidence to conclude that on average brand A coffee contains more caffeine? This is one-sided because of more. Mu sub A greater than mu sub B. Looks like that's what we're looking for evidence of. So there are the hypotheses. The alternative should be more caffeine on average with brand A. So mu sub A greater than mu sub B. So the null would be that mu sub A equals mu sub B. Using StatKey, the option we want is test for difference in means. And if I go to edit data, I'm going to leave the heading this time, since I never do it that way, just to show that you can. I've got it right here with A and B as the two categories, which seem like that would be the most straightforward thing to do. And notice here you don't have to adjust the null hypothesis. for a difference of means or a difference of proportions, it's set up to where the null is that they're the same, and then the alternative could be one-sided or two-sided, but the null is going to be that. Just need to generate 5,000 randomization samples, and then this is a right tail, and then the cutoff should be the difference of sample means, which is right here. It's 2.03, so I just have to change this cutoff down here to 2.03. There's the p-value, 0.182. Difference of proportions. If we're going to set up the hypotheses, you need that last bullet point. Is there enough evidence to conclude that the West Coast warehouse is not adhering to the policy as well as the East Coast warehouse? If the West Coast warehouse is not adhering to the policy quite as well, then the proportion would be lower. P West less than P East is what we're looking for evidence of. So that's what our hypothesis should look like, with W standing in for West and E for East. We're looking for evidence that the proportion is lower for the West Coast warehouse. So that's where our alternative should be, PW less than PE, and then the null would be that they're the same. In StatKey, the option that we want is test for difference in proportions. And then edit data. So for the West, we had 368 out of 400. For the East, 285 out of 300. $5,000 randomization samples. This is a left tail because of the less than in the alternative hypothesis. And then the cutoff, right here, the difference in sample proportions. It's not labeled explicitly as that, but where it says group 1, that's the sample proportion for the first group that you type in when it prompts you for the numerators and denominators of the sample proportions. Group 2 would be the second one, and then the subtraction order is group 1 minus group 2. So this right here is p hat sub W minus p hat sub E. So that's our cutoff, negative 0.03. So I just need to go over here, change this cutoff to negative 0.03. And 0.08 is the p-value.